we have completed 3 units or 3 modules in this course on electronics. Now we start the 4th module, which is on feedback in amplifiers, feedback configurations, modifications which the negative feedback can bring about in the amplifier performance, coupling methods and multi-stage amplifiers. In practice we see that one stage, that is single stage amplifiers, are of course basic for understanding, but when we talk of the systems, then normally we have to use multi-stage amplifiers. For example, operational amplifier, which we will be studying later, this is, you know it as a single unit. It is a integrated circuit which actually is a multi-stage amplifier. So how one amplifier can be coupled to the other? There are more than one possibilities. All have their advantages and disadvantages. So we will study all this in this module. Now first we start with the feedback. Feedback. First, the general introduction of feedback. I am sure you will recollect that we have used this term earlier too, when we were discussing the DC circuit design of amplifiers. That means various biasing schemes we discussed. Then you remember that we introduced one resistor with the emitter RE, and we performed the analysis. This RE, and we said that mathematically we showed that it brings stability to the circuit. By stability we mean that the circuit performance is not affected by various kinds of variations. For example, change in temperature, change in device. If one device goes bad, you replace it by another device which may have different characteristics, or aging. Aging is a use of the circuit for long time, then certain characteristics are bound to change. So this introduction of RE, the emitter resistance with the emitter lead of the transistor, was very important, and we said that whatever in this goodness, the stability to the circuit it brings, that is because of the feedback. Similarly, we talked about collector feedback bias. There also we talked about this term feedback. So first let us understand what is feedback, what kind of feedbacks we have to encounter. So feedback. In a amplifier, this is the amplifier. These are the two outputs and these are the inputs. The signal is given here and the signal is taken out here. Now you know what is the purpose of amplifier. The purpose of amplifier is to amplify the signal without changing its characteristics except its magnitude. So obviously the output in an amplifier is a function of input. Now very important that if the input is totally independent of output, that means output does not influence the input to the amplifier, then the circuit is called open loop. Open loop amplifier having no feedback. Having no feedback. Now let us see that this is not a good circuit, because here we will see that the performance will change as the situations which are bound to change will occur, for example temperature variation, etc. Now in this circuit the gain if we take voltages, at the moment we are taking voltages which are very frequently used. Otherwise remember this, in the whole analysis in this chapter, these both can be voltages as we are taking, and we are taking it because they are most commonly used, or both can be currents, then the gain will be the current gain, or one can be voltage, other can be current, then it can be a transconductance amplification factor. So but the analysis is valid for whatever is the amplification factor, but we will be considering voltages. So under when the input is in no way connected, is no way affected by the output, this is called open loop amplifier, and in this is gain is output to input. So since we are considering voltages, so output voltage to input voltage, or from here simply the V0 is equal to A into the input signal. Now suppose I will tell you what may change the performance. For any reasons the gain changes. If the gain changes from A to, say, the change is delta A, then so that it becomes equal to A plus delta A, then the output will change from V to V0 plus delta V0, and you know that we can simply write from here that the if this change delta V0 will be equal to change in A into Vs. So any change which occurs in the gain of the amplifier will be reflected in the output. This is not acceptable in most electronic designs. Now what may cause the gain? Let us see. Gain may change, for example, from temperature variations. Temperature change. Now temperature changes of 50, 60, 80 degrees are very common. And why the temperature will change? For two reasons. In summer and in winter there is a difference of 30, 40 degrees. More importantly, when we operate a circuit, then there are power devices like transformers, etc., and hence the temperatures, there are semiconductors which are temperature sensitive, the characteristics are bound to change. So temperature change is one factor which may influence the performance of the amplifier. The other is aging. Aging, that means use of a circuit for several months and years may change its performance, and then replacement of device. If we talk of the discrete circuits, then transistor or some resistors may go bad and they need replacement, and the characteristics of the device replaced may not be identical as the earlier ones. And so these are the factors, plus there are fluctuations, voltage fluctuations for example. These are the causes which may change the performance of the amplifier. Now, as I said, the changes of this kind, we are supposed to design a circuit which will not be affected by these changes. So, how we get it? This is achieved by feedback, by incorporating feedback. What the feedback does? It is a very important statement. Feedback, as the name suggests, a fraction of the output is mixed with the input. I repeat, a fraction of the output, if we are, as for example in the present situation we are talking of voltages, so a fraction of the output voltage is fed back, is mixed with the input. So the real input is the geometrical sum of the applied signal and the fraction which we are feeding back, and this is known as feedback. And this we will see that it will bring stability. Not only stability, there are various modifications which are desirable actually in an amplifier, and they can be achieved by using proper type of feedback. One thing again very important, we will not bother whether the circuit performance changes because of temperature change, aging or replacement or voltage fluctuations. The cause of the variation is immaterial, it is not important for us. We simply say that some characteristics of the transistors change, cause of change not significant, and we will design a circuit by incorporating feedback so that this proper design of the circuit takes care for all kinds of variations, and that we will show you soon. Now, there are two types of basic feedbacks. Two types of feedbacks. It depends that the two signals, the input signal and the fraction of the output which are mixed, how we are mixing, in what phase. So for example, one situation is when input, the net input which will be going to the amplifier, this is equal to the input signal, original input signal, and the fraction VF. VF, we will see later that this is known as return signal. This is the return signal, fraction of the output which we are feeding back at the input. So the phase of the return signal is additive, they are in the same phase, so that the effective input signal will be Vs plus Vf. This is original input signal and this is the return signal, and two are added up. In this situation we will see, even we can see it right from the fundamental equation, that if the signal increases then the output will increase. So the output now increases, hence this will give higher value of output, again higher fraction because the feedback network is constant. So, it will drive, for example, if 10%, then 10% whatever is available at the output. If output has gone high, the 10% portion which we are feeding is that also becomes high. So, this will keep on increasing. Now, this will finally it will amount to instability. If the output keeps on increasing every time, then this will bring instability to the circuit, and this is known as positive feedback. Positive feedback is avoided in amplifiers, but it is the requirement of oscillators. So, positive feedback, remember always, positive feedback is used in oscillator circuits. I said that positive feedback brings instability to the circuit, and so it is used in oscillators. In broad sense, what are oscillations? Oscillations are also periodic instability. A periodic instability, they are oscillations. So, by proper networking if we have a amplifier, if proper feedback is used, then we can generate a oscillator, and the networks which we use, they bring proper phase and proper amount of the return signal in oscillators. We will not talk further because oscillators is not our topic. We are going to talk about the amplifiers, the basic amplifiers, and how the feedback can modify the properties as we desire in an amplifier. So, positive feedback is to be avoided totally in an amplifier. So, always remember that positive feedback is to be totally avoided in amplifiers. When the purpose is simply to amplify, positive feedback is going to affect adversely the performance, and we talk about the second type of feedback, which is called negative feedback. In negative feedback, we return the signal which is having phase opposite to the input signal Vs. So, the net input to the amplifier is Vs minus Vf. F is the return signal and Vs is the input signal. So, this is the net input to the amplifier. This is negative feedback. Now, negative feedback can modify the circuit performance drastically. Modify means desirable modifications. What are the things which negative feedback can bring? So, modifications in amplifiers brought about by negative feedback. Following modifications are brought to the circuit. Number 1, stability. stability of gain against all sorts of variations. Negative feedback brings stability to the amplifier. Then negative feedback reduces nonlinear distortion. It reduces nonlinear distortion. By nonlinear we mean that, for example, if we look at the input characteristics of a p-n junction, which is the input part of the transistor, then these characteristics IV, this is base current and this is the voltage, this is nonlinear, this is nonlinear. It is varying like this, exponentially it increases. Slope here is different than here, than here. This is nonlinear. So here the same amount of variation of this voltage will give different amounts of current. If we double the voltage, current does not double in all regions. This is nonlinearity. So the negative feedback reduces the nonlinear distortion. Further, it increases the bandwidth. Increases the bandwidth. For example, the gain frequency characteristics, gain frequency characteristics in general for on an amplifier are like this, and this is called the bandwidth. This bandwidth can be increased by incorporating the negative feedback. So which is the requirement? Some applications like television and similar, there are situations we require large bandwidths. So how we achieve? We achieve by incorporating negative feedback. So increases the bandwidth. Then negative feedback modifies, by modification we mean it may increase or decrease, increase or decrease the input and output impedances. Input and output impedances are drastically affected, they can be changed quite a bit by incorporating negative feedback. Now how it is that negative feedback may increase or decrease, for example, the input impedance? Yes, because negative feedbacks are also of several kinds. We will see that these are 4 kinds. So we can choose the proper configuration out of the 4 possible configurations for negative feedback, and that will decide whether the input and output impedances will increase or decrease or so on. So these are the major modifications which negative feedback brings to the amplifier. No gain, no advantage is without paying a price. Negative feedback, all these advantages are, for that you have to pay the price. So what is the major disadvantage? The disadvantage is that by incorporating negative feedback, the gain of the amplifier falls. Gain of the amplifier falls. For example, the open loop gain may be 10,000, which is reduced to 200 when we incorporate negative feedback for various things we have talked about. But let me tell you this, fall in voltage is not a serious problem. We can add another additional stage to have the gain of the desired value. So additional stage, and you remember, two stages connected in series, the gains multiply. If we have a gain 50 and 50, two stages, when they are coupled, this we are going to study in multi-stage amplifiers. Then for the coupled amplifier, for the two-stage amplifier, each stage has a gain 50 50. So the gain will be 50 into 50, that means 2500. So fall in gain is not a serious problem, just one additional stage can compensate for that completely. So this was the general introduction for feedback, the positive feedback in which the return signal has the same phase as the input signal, and as we have talked that this brings instability, and hence in amplifiers this is avoided completely. The other type is a negative feedback in which the return signal has a phase opposite to the input signal, so that two are subtracted, and this is known as negative feedback, which can change the parameters in our favor, and the circuit performance can be improved drastically by incorporating negative feedback. Now having said this, we go for general feedback relation. General feedback relation. What is, first I draw in block diagram the basic feedback amplifier, and then I will explain the terms which are used, and you should get familiar with these terms. Now the basic circuit is this. Basic amplifier having gain A, and this is the feedback network. And having gain B, feedback network. Don't be afraid, it is not a complicated network. Network feedback will contain mostly one or two resistances in the additional resistances in the circuit to incorporate the negative feedback of your requirement, to meet your requirement. And here this is the output, fraction of that is taken by this network to be fed back. This is the point which we call summation of the two. We are considering voltages at the moment, and so this is the applied input signal Vs, and here this output is V0. So obviously this is V0, and this goes in this, and here it comes out as Vf, and these two are mixed here, and then this goes here, and this is known as VE, which is equal to Vs minus Vf. This is the net signal here at the input. Now this is the basic amplifier which has open loop gain A, and since we are considering voltage amplifier, then A will be the ratio of the output to the input to the amplifier, and this whole, when we incorporate the negative feedback, this whole is the negative feedback amplifier. Amplifier with negative feedback. Now, what are the terms which we are using? They are very important, and that you should remember always. When we are talking of feedback, you must remember these terms. Various quantities involved. First of all, A. A is, remember this circuit, A is the gain of the basic amplifier, and this basic amplifier is the open loop amplifier. This whole becomes closed loop amplifier with feedback. A open loop gain of the amplifier. Open loop gain, that means gain without feedback. And B is feedback factor or gain of feedback circuit, gain of feedback circuit. Gain always, you see, is defined as, since remember often I am reminding that we are considering voltages, so here this is output voltage to input voltage. Here this is the input to the V0 is the input to the feedback network, and output is Vf. Therefore, B is equal to Vf by V0. And what is Bf? This is very important relation, you should remember, and Vf is feedback voltage. And V0 is output voltage. Output voltage. When we will consider, suppose we consider this as current, this also as current, then this will also be the current, then A will be the open loop gain of the amplifier, which will be the ratio of the output current to input current. Similarly, V will also be in the current form, the output current and input current. So, there is no confusion, but we will always use in our discussion the voltage amplification. So, we are considering voltages, and VE, this signal which is actually going to the basic amplifier. So, VE is called error signal. Error signal in general, and since we are considering voltages, so this is error voltage. Why error? Actually, this is the corrective voltage. Now, the input which is going to this amplifier is not constant as Vs, but it will vary with Vf. And error, because the effort is that this error should be minimum, that this factor becomes clear to you later. So, these are A, B, Vf, V0, Ve. These are the parameters which we are using. Now, what are the relations which exist among these various quantities? Remember this circuit, and we can see this. Their relations are V0. V0 is gain into VE. Here, for this amplifier, A is the gain. So, A is equal to V0 by VE, because V is the input to this amplifier, and so V0 becomes A into VE. This is what I have written. And VE, the error signal, is simply Vs minus Vf. And what is Vf? Vf from here, B is the feedback factor, gain of the feedback circuit, and this is Vf by V0. So, Vf is B into V0. Let us call this equation 1, 2, 3. Now, we substitute Vf from 3 into 2, then we get VE is equal to Vs minus V into V0. I have just put for this Vf from here, and this value it put, substituting this value of VE into equation 1 here. So, what we get? V0 equal to A into Vs minus B into V0, or we continue simple analysis. From here we get V0 into 1 plus B into A equal to A into Vs. Now, gain of the amplifier, gain of the feedback amplifier or amplifier with feedback, gain of the feedback amplifier is, this is the feedback amplifier. To that, output is V0, input is Vs. Vs is the signal strength which we are feeding, and so this total amplifier has input as Vs and output is V0. So, then we have, and we write this gain as AFB, FB for feedback. A was open loop gain, that means gain of the amplifier having no feedback. This is with feedback. So, this is obviously equal to V0 by Vs, and from here, from the top, from this equation, it simply becomes equal to A 1 plus VA. This is the relation among various quantities of interest. So, this is the fundamental relation. Very important relation. Wherever a feedback analysis is used or feedback quantities to be calculated, this relation will be used. the gain A falls in feedback network 1 plus BA, and all quantities which will be modified, they will have the parameter 1 plus BA. And remember, A is the open loop gain and B is the feedback factor or gain of the feedback circuit. Now further, very important thing, I just remind that negative feedback we have already taken into account when we write VE equal to Vs minus Vf. So this minus sign itself shows that negative feedback is under consideration. We are taking into account negative feedback. This is the fundamental relation for negative feedback. When it will be positive feedback, then simply this sign will be minus, that's it. The expression for positive feedback becomes AFB equal to A divided by 1 minus BA. So forget about positive feedback, we are talking about negative feedback. This is the basic equation. This quantity AB, BA, which will appear in all the relations, is called the loop gain. BA is called loop gain, and we have been saying this, that a amplifier with feedback, with negative feedback, is a closed loop amplifier. Open loop without gain or without feedback, and then the gain will be A. We will be using this expression where we will see that how the quantities of interest get modified, how the gain stability is obtained, how the distortions can be reduced. All this we will be studying. So in this relation we should use, we should remember what are the quantities. First we talk about gain stability. Gain stability. By stability, I repeat that the gain, and currently we are considering voltage gain. So the voltage gain should not be affected by temperature change, change of device, and so on. So we are now showing that how the gain will be made stable by using the negative feedback. So the basic equation AFB is equal to A 1 plus BA. Let us see that if BA, this quantity loop gain, is made large as compared to 1, is very large in comparison to 1, then 1 can be dropped here. Now this condition can be easily satisfied, and in practice this loop gain is kept quite high by taking the A, the open loop gain, very high. We will solve certain examples and we will see when we say high, very high, what we mean. So anyway, so if this is the condition, then we can drop 1 in comparison to BA, and AFB becomes equal to A by BA, or this will be equal to 1 by B. That means AFB is equal to 1 by B. This expression, the gain of the feedback amplifier, is totally independent of changes in A. See this expression? because if by design VA is high as compared to 1, 1 is dropped, then this is the expression, and mathematically simply we see that gain is totally independent of A. So, the variations are certainly not going to affect at all the closed loop gain. The gain stability will depend on the B, and what is B? That is the gain of the feedback circuit. This is the feedback circuit, and as I said in the beginning that here there are only 1 or 2 resistances. So, they are anyway quite stable. So, this is high stability to feedback amplifier. Now, this becomes clear to you further, the quantities which I have been using, you should get familiarity with them, and for that we must solve a simple example. Very simple example I take, that how we can calculate, for example, open loop gain, closed loop gain, and the gain beta. These are, I take a simple example. Simple example, and I give a circuit in the block diagram itself, then we will go to actual circuits. That here is the amplifier, and this has a open loop gain A, and here this is the feedback circuit, feedback network, which has a gain B. This is V0, this is fed here, and this comes out here. Now, I assign the values. This is, for example, 0.3 volts, and this is around 3 millivolts, and this error signal here, which is going to this main amp, this is Vi, the error signal Ve is 3 microvolt. Then in this circuit we have to find out what is the open loop gain. Open loop gain A we have to find out. Closed loop gain AFB we have to find out, and we have to find out the gain of the feedback circuit, feedback factor as we call. So, gain of feedback circuit, that is B. These three quantities we have to find out. Very simple, we can get it, the solution. First we can find out what is A, the open loop gain. Open loop gain is the output to the input of the amplifier, and the output is 0.3 volts divided by 3 microvolts. So, this is 0.3 volts divided by 3 into 10 to the power minus 6, and this is obviously gain A becomes equal to 10 to the power 5. 100,000 is the open loop gain. And what is the factor B? That is the gain of the feedback circuit, also popularly known as feedback factor. This is, as we have been using all through, this is Vf by V0, and this is equal to this is the input 3 volts 0.3 volts to the feedback circuit, and the output is coming 3 millivolts. So this is 3 millivolts by 3.3 3 millivolts by V0, and by V0 is 0.3 volts, and this comes out to be 10 to the power minus 2. So we have got the value of A 10 to the power 5, B 10 to the power minus 2. Now we use the basic relation AFB equal to A1 plus BA. This is equal to this quantity open loop gain 10 to the power 5. This is 1 plus this is 10 to the power minus 2 into 10 to the power 5. So that AFB is equal to 10 to the power 5, 1 plus 10 to the power 3. Obviously we can neglect 1 easily, so that it is equal to 10 to the power 5 by 10 to the power 3, which gives the closed loop gain as equal to 100. These are the 3 quantities which we have found out. The open loop gain was 10 to the power 5 and closed loop gain is 100. So there is a reduction, but as I said, this is not a serious problem. So this I took, this example I took so that you get a clarity in the use of the various parameters A, AF, B, B, because these are the requirements for this expression. And as I said, we will continue that all quantities are basically modified by this. Here you can further confirm, because in this expression AFB, this is A1 plus BA, and BA is very high, so 1 is neglected. So then gain comes out to be this, which you can see here too, that this was 10 to power, this is 10 to power minus 2, and this gives AFB again equal to 100. We will continue.